Hi, I'm Bilgekağan Çanak. I am second grade computer science student at Bilkent University. In this video, I am going to introduce my Physics 102 project, which is investigation of Faraday's law, effects of number of turns, and coil radius on induced EMF. And my aim is to study how the winding and cross-sectional area of coil affect the induced EMF.
My materials I used in this experiment are, as can be seen here, a digital multimeter, a ruler, a magnet, crocodile cables, 3 coils with different number of turns and same radius, 3 coils with different radius but same number of turns, scientific calculator, and stopwatch. The procedure that I followed throughout in this experiment, as can be seen here, is the following. First, I gathered the equipment which I needed for this experiment. Then prepared coils to start my experiment. In the first part of my experiment, I performed experiment with constant radius but different number of turns in each coil. With 3 different winding, I got these results. In second part, this time I performed experiments with constant number of turns but different radius in each coil. With 3 different radius, I got these results. After doing experiments and finding experimental values, I calculated expected values by following this theorem, Faraday's law. By dropping a magnet through the center of the coil, the resulting change in magnetic flux induces a peak electromotive force governed by the relation induced EMF equals minus number of turns times cross-sectional area times rate of magnetic field change. By keeping the drop height fixed to maintain a constant field change rate, I establish the theoretical EMF values based on the specific number of turns and the cross-sectional area of each coil, which allows for a direct verification of the predicted linear proportionality. And then, performing this error calculation formula, I found the percentage errors. This table is the results of my first part of experiment with theoretical values and percentage error. Similarly, this table is for my second part of experiment. And these graphs are for these tables.
In summary, my experiment confirmed that increasing the number of turns and the coil radius increases induced EMF, verifying the linear relationship predicted by Faraday's law. Despite minor errors from air resistance and magnet fall angles, the results consistently followed the expected theoretical trends. These findings successfully demonstrate that the physical properties of the coil are primary factors in determining the magnitude of electromagnetic induction.